course.
Oh yeah, one more thing. I'm on the Zoom free tier. So the sessions, it'll kick us out after like 40 minutes. I have to send you a new link on Gmail later.
Oh, okay. Yeah, it's
Yeah.
good.
Okay, so what are your goals and what do you hope to get out of these sessions?
So my goal is I want to learn specifically Java, or better said, object-oriented programming,
Okay.
since that is also part of the curriculum for my studies in business informatics. I do have some experience with Python, a little bit of C++, but it's just very basic stuff. So I cannot really say I have built already like a project or anything like that. Um, yeah,
Hmm.
what I expect to get out of this is well, the knowledge, and I'm very thankful for your time as well that you're doing this for free.
Yes, of course.
So I also want to make good use of your time. Uh,
Okay.
yeah.
All right. So one thing to note is that I don't usually start students in an industrial programming language. I usually start in a student language. In
Mhm.
your case, it sounds like you do already have some experience. Mm,
Very little. So if we
okay.
start with the student programming language, even better.
Okay. Okay. I need to, okay. So I think for the first session, I need to first get a sense of where you're at so I can
Mhm.
better calibrate like what I should like, uh, how I should conduct the sessions with you. Do you have Visual Studio Code by chance?
Yes, I have it installed.
Okay. Okay, I'm going to do something different with you. This is the first time I'm going to do this, but I'm going to use Visual Studio Code Live share with you.
Okay.
Um,
Yeah.
yeah, okay, just give me 1 second. I'm going to put that up on my end.
Mhm.
So the reason why I'm going to use Visual Studio Code Live share with you is because it will let us make it will make us make quicker progress. I found that yeah, for absolute beginners, I usually get them to open a link and I tell them what to type, but that's pretty slow. In your case, I think we can move a little bit quicker.
Okay, let's try.
Okay, give me like 1 minute as I set this up.
Mhm. Yeah, sure.
Okay, I'm gonna send a link in Zoom chat. Let me know if you can click it.
Yep. Okay, I click it. It tells me how I would like to join. Should I continue in the browser or should I open in the application?
I recommend the app.
Okay.
Yeah.
This installing the live share extension. Do you hear me?
Yeah, I hear you.
Okay. It's telling me, well, I'm trying to trust the workspace, or wait, and I need to tell the folder. Okay. Okay. Yeah, I'm here.
Oh, okay, I see you.
Yes. And yeah.
Can you try typing something into do you see a file called sunset.arr? Okay, I see it.
Uh, you see what I wrote?
Yeah, it's like yes, smiley
Yeah.
face, right?
Yeah.
Okay. Okay, let me think about how I want to do this. Okay, and you can see what I write as well. A plus B.
Yes. A plus B. Yes.
So how does it look like on your end? Does it like does the text just show up immediately or do you see me typing it out?
It I see first the A, then the plus, and then the B.
Okay.
It's like, yeah.
Okay, yeah, all right. I think I'm getting this.
Mhm.
Okay, yeah, this is my first time doing this. Okay, so it's gonna be a bit rough, but hopefully it'll be all right. I'm gonna I'm gonna share my screen, but this is for the Zoom recording. You can just look at your Visual Studio Code live share.
Mhm.
Uh, okay, let's share my screen. Okay, so let's begin. Could you try adding two numbers?
Adding two numbers, like
Yeah.
1 plus 2.
All right, at the top right, there should be a blue button run. Do you see it?
Top right.
Ah, wait, actually, I don't think you
Mm,
see it.
no, I.
Okay.
Mhm.
Could you go to the left-hand side? There should be a thing called extensions.
Mhm.
Click on that, and I want you to search up Pirate, Pyret.
Pirates.
You see it?
One moment. Yeah, interactive editor for VS Code. Okay.
Oh yeah. Yeah, please install that. So this is the extension for the programming language that we're using.
Oh,
And once you
okay.
install it, it should look like what you see on my screen. There should be a white bar at the top, and there should be a run button.
Okay. So
Let me
let
know once you see
me.
that.
Yes, now it's loading something and then, okay, run. And if I click run, it tells me the operator must have a white space. Like
Oh,
this.
okay.
Yeah.
Okay, interesting. I cannot see what you run. Okay.
Ah, you don't see
Actually,
the. Uh-huh.
could you share your Visual Studio Code live share instead? Okay,
Yes.
I'm gonna stop
So,
sharing mine. Yeah, just so I can see your results.
hmm, hmm. So, do you see my screen?
Yes. Yeah, okay, 1 plus 3. Okay, and what you notice is that you need space around the plus operator, right?
Yeah. I mean, it gave me the, like, it told me when I
Y-
did it like this, it showed a message,
Yep.
white space.
Very good, very good. Okay. Okay, now could you try subtracting another number? Like, don't delete anything and try subtracting another number.
Uh-huh.
No, no, but in the same line on line 4.
Ah,
Yeah.
okay. Hmm. Do I need to just add a number like this?
Oh, yeah, yeah, perfect. Yeah, let's run it
Ah,
and see what
okay.
happens.
Mhm.
Oh, what's happening here?
Parentheses. Ah, okay, I need to add parentheses. So first this. I don't know if you're gonna run negative numbers. Oh yeah.
Hmm. All very good questions. And yeah, so notice how this language it doesn't know whether or not to add the plus first or minus first. You have to tell it.
Mhm.
So are you familiar with bedmas or pandas?
Mm, Pandas. I think it's something from Python, right? The
No,
extension.
no. So no,
Oh.
this is from mathematics. That's a convention for order of operations, like multiply
Ah,
before you add, right?
yeah.
Okay, this programming language does not know what that is. You have to specify it manually.
Okay.
And the reason for that is because there are many more. operators. And so PEMDAS is only 6 letters. If you want the PEMDAS for this programming language, it's going to be like 20 letters. So you've done C++, right?
A little bit, but I
Okay,
mean,
a little bit. So
very
like,
little.
so I'll show you some simple phrases. C++ there's this symbol, there's this symbol, there's this symbol, there's this, there's this.
Yeah.
There's more that I can't think of at the moment, but like, imagine memorizing the order of operations for all of these. So many,
hmm
right? Okay. So that's the first idea, order of operations. Now I'm gonna usually for absolute beginners, I tell them to write this themselves, but since you have some experience, I'm gonna write this out for you. Um, what will this produce?
Mm, hmm. So I'm just wild guessing here, but the minimum, this means minimum and this number. So
So what does it
minus
produce?
one, maybe minus one or one. If the minimum is will be four and minus three,
Okay,
one.
let's run it. Let's see.
Oh, three.
Three. Okay.
Um,
Okay, let's
So it
change the
takes the
numbers around.
minimum.
Oh, so you say it
hmm
takes the minimum. Okay, let's see. Let's change the three to a bigger number and let's see if it produces four.
Okay, should I do it?
Let's do it.
Okay. So now it should be four if it's the minimum. Uh-huh.
Okay. So it seems like it gives you the low of the two numbers, right?
hmm
Okay. Notice how we were like doing arithmetic just now with symbols, but now which are math operations, but now we're doing math operations with words. Num min.
Okay. Num is telling the program that inside are integers. Is that right?
Oh, numbers.
Numbers.
Okay, since you're more advanced, I'm going to show you something. I'm going to do this. What do you think that will produce?
4.4?
Okay, let's run it. Let's see.
Yeah.
Hmm. So
Okay.
it's more than just integers, right? It
Okay.
includes decimals.
Doubles. Mhm.
Yeah. I don't want to say doubles just because
Okay.
double is like a specific implementation detail as to how it's represented by the computer. Let's just say this is a number for now.
hmm
So this is a function. We're applying a function. Now the num at the start, in theory, this function name could be anything. It could be banana for all we care. But we want to give our functions descriptive names. And in this programming language, all number math operations, math functions begin with num dash. This tells the programmer this function does operations on numbers. Okay.
Okay.
And the min part is just the name for what it's doing. So it's finding the minimum of the numbers. Okay.
Okay.
All right. Now I'm gonna do something different. I'm gonna do this. All right. What do you think this does?
So it's print one. I guess
All right, let's
it's
run it. Let's see.
mhm. Yeah.
Okay, so variable substitution, right?
Yeah, it a substitution. Well, I mean, yeah. Um,
Okay.
for a
Now, what if I
summation.
do this?
Mhm. Then it will do a two.
Okay, let's
It
run
will
it. Let's see.
replace. Okay.
Oh,
Ah,
what's happening
okay.
here?
If a name conversation earlier. Ah, okay. So you cannot have the. It doesn't accept the second one.
Hmm. Now, imagine if we're a mathematician and we write let x be 1, and then we immediately write let x be 2. Wouldn't that be weird? It's
Mm-hmm.
like we already defined x the first time. Why are we defining it the second time? So this is a very mathematical idea. We call this declaring. All right, we're declaring a variable. We'll say
Okay.
x is 1. And if you say x is 2 later, it's like, why are you doing that? We already said x is 1. Now, here's the thing. Different programming languages will have different results for this. In Python, this would have printed 2.
Hmm.
Yeah.
Because it will replace, right? I mean, that's how I understood it back then.
Yes. Um, we would call that mutation. So we're saying we currently do not have mutation.
Mm.
Uh, okay, since you're a little bit more advanced, I'll tell you this. There's a difference between uh initialization and reassignment. So like when we say x is one for the first time, we are initializing x to be one. But in a language with mutation, in fact, I believe this language actually has mutation, but we are saying that if we say like, oh, x is two now, we're saying we're reassigning x to two.
Hmm.
But that's a little bit more of an advanced idea, which we will revisit in the future. Um, but for now, just know this, that you can't actually redeclare a variable with the same name. Okay.
Okay.
But I guess no surprise, if I delete the first line x equals one, this, what do you think will produce?
A two. Now a two.
Okay. Okay, great.
Should I run it?
Yeah, run it.
Okay. Yeah.
Very nice. And then, we can go very crazy, right? We can do things like x equals y equals one, and what do you think this will produce?
Mm.
One, right? So
Well,
let's run it.
it's printing an X. Ah, yeah, yeah. Wait. Ah, yeah. So yeah, a one. Yeah.
All right.
Brain
So
fart.
now we can also assign variables to variables because when the programming language sees x equals y, it's going to see, oh, the y is a one. So it's going to see x equals one. So x is going to take on one, right?
Hmm.
Okay. Okay. So yeah, we can go really crazy with this, but I do want to show one last thing, which is let's go back to x equals one. What happens if we do this? Before we run it,
What?
what do you think is going to happen?
I think there will be an error because it's already tell me what is X before it even knows what the value variable X has inside.
Okay. Yeah, let's run it. Let's see what
Okay.
happens. Hmm.
Uh-huh. Unbound.
Unbound. Oh yeah, so okay, since you're more advanced, I'll tell you this. So this is called the binding of var when you declare a variable, we can also say we are binding. Uh Binding, it just means we're giving a name to a value. So like when we say x equals one, we're saying, okay, when we're giving the value one a name, it's going to be called x. And so whenever we see x, it's actually one.
Hmm.
Okay, that's not super important to know, but it's good to know. But yes, you are correct. So notice there's a notion of time, right? The programming language, when it reads your file, is actually going from top to bottom. So when it sees x
Hmm.
first, it's not going to know that x equals one because it hasn't seen that yet, and it's going to be confused.
Hmm.
So this is like order of operations, what we talked about earlier, order of operations, but across many lines. First,
Uh-huh.
in this case, it's like, oh, we're trying to access the value of x, and then we're trying to define it. There's an order to things. It doesn't happen all at once, and it doesn't work here because the definition hasn't happened yet.
Hmm. Okay.
Okay, all right. And by the way,
Understood.
what we're doing right now, it's very important because like I'm always giving you like, oh, this is a program, run it. Okay, before you run it, guess what's gonna happen, and then run it. Um, this is a really important thing, not just in computer science, I feel like, but I feel like whenever you're able to have very fast feedback, try to make as many guesses as you can and try to predict things and run it. This trains your understanding
Hmm.
of what's going on.
Okay.
Yeah. Okay. Let's move on from variables. So basically, just to summarize what has happened so far, we are exploring mathematics with a computer. When we first started out, we're using this programming language, like I asked you to add one plus one, for example, it's like using a calculator, right?
Hmm.
And now we are exploring the laws of algebra. We moved on from arithmetic, we are exploring the laws of algebra. We have variable substitution. And now I'm going to bring up another law of algebra. Well, not a law of algebra, sorry. I mean like an idea of algebra, which is function definitions. Do you remember seeing this?
Yeah, I remember.
Like f of x equals x plus 1? Well, we're going to do that here. So, okay, the
Uh-huh.
syntax for this is a little bit funny. So I'm going to teach you how to write functions in this language. It's going to be a bit different from what you have seen in other languages. So humor me for a moment. First, you
Mhm.
must write fun. Now notice that fun is in a different color.
Mm-hmm.
So this is a keyword. We're telling a programming language we are writing a function here. Next, you write the name. So let's say I want to name my function f. Opening parentheses, and then you write your arguments. Let's say, sorry, your parameters. So let's say it takes in one thing. And now we want to produce x plus 1. Once we are done, we have to write end n. Now, if you notice, if you will see this whole thing is highlighted now. I don't know if you can see it.
Yeah, yeah, I can see it.
So it's highlighted because the programming language sees that, oh, it's a function. So there are three parts. There's a name. Now this name is f. There is parameters. Oh yeah. Before I talk about parameters, let me ask you, what's a function?
It's like a graph, I remember. Like you plot points towards x and y axis and shows you a curve or a graph.
Yeah. Well, that's not wrong, but the fact that it's a graph is more of a way of visualizing the function, right?
Yeah.
But the idea of x and y axis, what does that mean about the function? What does it mean to have an
Mm,
x and y axis?
something that, well, it has two dimensions, so it could be like a description of something across these two dimensions in time, like for example, time and velocity.
Yes. Well, to generalize this even further, we say that a function is something that goes from input to output, right?
Oh, okay.
You give it something, it gives you something back. You give it time, it gives you velocity. So
Mm-hmm.
like x and y
Mm-hmm.
axis, what the graph is actually telling us is telling us the relation between, well, using your terms, two dimensions, right? From what's the relationship between the x and y, the inputs and outputs.
Mm-hmm.
So that's what a function fundamentally is, inputs to outputs, and nothing else. So in theory, if I tell you this function adds one, you don't even have to look at the body. Like I could like hide this from you. Hold on, let me delete the body. If I tell you like, oh, this function adds one, you don't even have to look at the body. You know that, oh, given a number is going to add one to the number, right?
Oh, yeah, okay.
Okay, now I would like, so one thing about programming is, and this is where it differs from mathematics in real life, is we like to give our functions descriptive names. Mathematicians, they like short and sweet names because they don't want to write as much as they can, right? They want to write short things.
Mm-hmm.
But for programmers, we don't write with our hands. We write programs, and so it's much faster than writing by hand. I want you to change this function name to something more descriptive. What would be a good function name here?
You mean to replace this f?
Yes.
It's more descriptive. I don't know. X
What is this
plus
function
one.
doing? Just
It's
sorry.
adding addition. It's an addition.
Okay, and specifically, how is it performing addition? Can we be more specific than addition?
It adds
Okay, what is
one.
it? Adds one.
So x plus one, plus one.
Okay, plus one. Okay, yeah, let's do it. Let's give it the name plus one.
Should I write with this? Because I think plus one.
Oh,
Okay, it has different
actually,
colors, so
wait.
it's telling me.
I think that's illegal. Wait. Can we try that? Can you
Sure.
run it? Because okay, it doesn't like
Uh,
it. Okay, in some languages that would have worked, just not this one. Um, okay, so we can't use that symbol. It doesn't like that. What's
uh,
a different? How can we say this differently?
plus one. But
Okay,
it's very
let's
long.
try it. No, it's five letters is
Okay.
very short, man. There's much lot of functions in this world. Okay, let's
Okay.
run it. Okay,
Okay.
nothing happens, right?
Yeah.
Now, what if I actually wait? No, actually, let me ask you, how will we use this function?
I guess we will need some way to type into the program, right? Like it expects us to tell it what it's X, what we want X to be.
Yes. So how do we do that?
Um, the inputs, like there should be a way to give to for the program to receive an input before.
Hmm. It needs to take in an input, and how do we do that?
That's a good question. Uh, I don't know. This is the moment I will probably ask, go to the documentation and find how to do that.
Okay,
But
but
I
I'll tell
guess
you.
input, yeah.
I'll tell you. So as I'm your documentation today. So it's very similar to Python and Java and C++, and this is basically true for just about any programming language in the world. To use a function, and in mathematical speak, we are saying we are applying a function, or in programming, we say we are calling a function. To do this, first, we need to say what is that function. So we need to refer to it by its name. Next, opening parentheses.
Oh.
Next, any number you want, what the arguments. So in our case, plus one takes in one number, so we give it one number, and then closing parentheses. Okay, can you run it for me?
Hmm. Sure. Uh-huh.
Okay. So just like, okay, so you are right, you had the right idea, right? Like, okay, we need to use this function, we need to give it inputs. How do we do that? First, refer to it by its name, plus one. And next, opening parentheses, pass in the arguments, closing parentheses.
Uh-huh. Argument
So,
is always the name of the number inside.
so yeah, so I have used these two words so far, parameters and arguments. On line four, that x, we call that a parameter. Four, five,
Uh-huh.
six, we call that an argument.
Okay.
So parameter is like the variable, it's like the generalized thing. Argument is the specific concrete thing. Like 456, that's a specific number. Yeah.
Great. Thank you. Okay. Mm-hmm.
You don't have to know this, by the way. Like people will mix the two and it's okay. As long as people know what you're talking about, it's fine. Yeah.
Okay.
Okay, okay, so let's do something different. Notice how there are two windows.
Mm-hmm.
So we have been writing the left window, right? And when we run things, it's been giving us answers on the right side.
Yeah.
I want you to click on the right window and I want you to call plus one with a different number and then hit enter.
Here? Ah, I can write here. Okay.
Ah, yeah.
Didn't
Can
know
you write
that.
plus one and then pass in a number?
Um, okay. And then enter.
455? You enter here. So it gives us
Okay.
456. So I got some
That's
explaining to do. Notice how
mm-hmm.
it's able to use the names on the left-hand side,
Mm-hmm.
right? We define
Mm-hmm.
plus one on the left-hand side, and now on the right-hand side, we can use it.
Yeah.
So we call the left-hand side the definitions window, sometimes might hit definitions pane. For my
Mm-hmm.
purposes, I'll just say it's a window, so definitions window. The right-hand side, we call it the REPL. That's REPL. It stands for, so R for read, it's reading your inputs. E for evaluate, is evaluating what you write.
Uh-huh.
What is evaluate? Evaluate means to make a value. What is a value? Basically numbers. Numbers are values. A value is a thing, it's the most simplified thing, like a number. You can't do anything more to a number. But if we say like
Mm-hmm.
1 plus 1, there's not a value. The ones in 1 plus 1 are values, but 1 plus 1 itself is not a value. But once we add 1 plus 1, we get 2, that's a value. So when we
Okay.
say evaluate, in mathematical speak, we're saying we're simplifying. 1 plus 1 is 2. Oh, we're done.
Mm-hmm.
Yeah, so evaluate is to make a value. So it reads what you write, then it evaluates. So plus 1, 455 is going to turn that into 455 plus 1. It's going to evaluate that again into 456. So evaluate. P for print. Once it evaluates it, it's going to have a value. So 456 is
Mm-hmm.
going to print it out so we can see it with our eyes. And L is for loop. So you can keep doing this again and again. So REPL, REPL, read, evaluate, print, loop. Okay.
Okay, okay. Mm-hmm.
And we don't have to call functions. We can, for example, if you write like, if you add two numbers in here, it will work. Can you add two numbers?
On this one.
Yes.
Ah, wait.
Okay.
Oh, okay.
So notice how we don't have to run the program. It just works.
Mm-hmm.
So this is like a one-line program that we do not have to run. We just hit enter. So this gives us very fast feedback. Okay.
Hmm.
This language is designed for beginners. And so this not all languages have this feature, by the way. I mean, but
Hmm.
this language is designed for beginners, and what's important for beginners is very fast feedback. And so this is a feature that gives the beginner very fast feedback. So, outside of our sessions, if you want to get some practice, if you just want to try stuff out, I encourage you to go through this, play around with this. I think you'll learn a lot from it.
Okay, yeah.
Okay, so we have covered function definitions and using functions by calling them. Okay, by the way, everything we covered so far, yes, we are programming, but I wouldn't really consider it programming. It's more like I'm teaching you the mechanics of what's going on.
Hmm.
Like for example, like a mathematician that just does plus, minus, times, and divide, like sure they're doing mathematics, but like there's more to mathematics than that, right?
Yeah, yeah, a lot
So
more.
yeah, there's a whole dimension to this that usually isn't taught in computer science curriculums, and I'm gonna teach that to you now. And this is it's gonna sound very philosophical, but I promise you, it's the foundations for everything that we'll do. Okay, could
Mhm.
you delete everything on the left-hand side?
Yeah,
And I would like you to write five, just the number five. Okay,
like that.
now I want you to run it. Okay, nothing special, right? We write five because it's five.
Hmm.
Okay, now what does five mean?
Mm, well, it's a value describing
It's a
the
value,
amount of something.
amount of something. Cool. Okay, now let me ask something a little bit different. What is 5
Mhm.
degrees Celsius?
Um, Describes the temperature. Like there is a context now. Celsius temperature.
Right? How cold, how
Uh,
hot something is. Okay, how about 5 kilograms?
well, yeah, description with the weight.
Okay, wait, like how
There's
heavy, how light something
context.
is.
Yeah,
So additional context, right?
yeah, yeah.
Okay. But notice how they're all 5, and it means something different depending on whether or not we say temperature or kilograms,
Yeah,
right?
completely. Hmm.
So there are two worlds. There is the world of information, which is facts and ideas about the real world, and there's the world of data. This is what the computer understands. So when we say like 5 degrees Celsius, that is information.
Hmm.
But the computer doesn't know that it's temperature. The computer is only going to see 5. It just sees a number. That's data,
Hmm.
right?
Yeah.
So I'm going to make a claim that our role as programmers is to facilitate the interaction between these two worlds. Our job is to convert information into data, process the data. Okay, great. So our
Perfect.
job is to convert information into data and convert data back into information. So we say the converting of information to data and coding. Sometimes you might hear, oh, we're representing information as data. For example, we are saying we are representing 5 degrees Celsius as the number 5 in our program.
Hmm.
And converting data back into information is technically decoding, but that's not as important, uh, for our purposes at least. Okay, so I'll give an example. Let's say we have an electronic thermostat. The electronic thermostat is going to take readings of the natural environment. It's going to be a bunch of numbers, and the device is going to no, we get like the computer inside the device is going to see a bunch of numbers and it's going to perform math operations on them to deduce the number. That is the temperature.
Hmm.
Now, the computer isn't going to know that's the temperature, but it's the temperature. And once it has that final number, it's going to display it on some display. And we as a human, we're going to see 5 degrees Celsius. So that number, the data, becomes information again, becomes
Uh-huh.
temperature. So everything that we'll do as programmers is to go between these two worlds, essentially.
Okay.
Cool. Okay. Um, so again, it sounds philosophical, but it's going to be the foundation for everything we'll do. Uh,
Hmm.
so I got more philosophical questions. Right now, just to reframe everything we have done so far, we have been encoding information as numbers and we have been performing operations on them. We've been doing arithmetic and algebra with numbers. Now, here's the question. Can we encode all information as numbers?
Hmm. It's very philosophical. I guess no. I mean, there there are things that are intangible, like even with eyes and or senses. I don't know, feelings, for example.
That's a good answer. But I have a counter argument. Do you know how they say computers are a bunch of zeros and ones?
Yeah. Hmm.
Computers are a bunch of zeros and ones, so everything in the computers are numbers, right?
Hmm. Wait. But I mean, what those zeros and ones mean? It's like input output of electricity of
And what is electricity? Aren't they just
yeah.
charges?
I'm thinking. Like I mean, it's
Right.
electrons moving through a field which, if they
And,
surpass something like a threshold, then they give a one. Like that's like this threshold is
and a field.
enough.
Isn't a field just
Yes,
a numbers as well? A field can be described with numbers. Well, equations,
enough.
right?
Yeah, yeah. I guess yeah.
And what you mentioned about thoughts and feelings, aren't they just like electrons in our brain, electricity in our brains?
Oh well, I think yeah. Well, it's I guess that's a question for the neuroscientist. What exactly is consciousness? I mean, highly
Mm,
debated topic, but
okay. Well, here's what I'm trying to get to.
yeah.
Um, so in theory, we can encode all information as numbers. But here's the next question. Do we want to?
Mm, mm. Guess depends what you're trying to achieve.
So are you saying that there are situations we do not want to use numbers for?
Mm. Jesus, I don't know.
For example, like me and you, we're talking right now, but we're not talking in
Uh-huh.
numbers, right? We're not talking in Morse code. We're using language, which are not
Mm,
numbers,
exactly.
right?
Yeah.
Okay, so here's the thing. Yes, in theory, we can encode all information as numbers, but we don't really want to because that's not very useful to us. Like,
Mm.
um, since you're a bit more advanced, I'll tell you, like, if you've done C++, you might hear things like ASCII or Unicode. All these
Yes, yes.
are numerical representations for alphabets.
Mm,
So we can encode language into numbers. But here's the thing, when you and I talk, we I'm not talking in binary. I'm not saying people, people, right? I'm using words.
mhm,
So we're thinking on a higher level than numbers. We're thinking differently than numbers. You know how they say like the universe is just a bunch of
mm.
particles?
Yeah.
In front of me is a table, but I don't see, like in the eyes of the universe does not see a table. It's just a bunch of particles. But I see a table because that's how it's useful to me, right?
Mhm. Mhm.
So that's a second facet to all this, which is that we think it needs to be useful to how humans think. A number might be perfectly fine, like 5 degrees Celsius, a number is perfect. But you and I talking, we don't talk in numbers, we use language, we use words. That's more useful, even though it can be represented with numbers. We prefer to use words.
Mhm.
Okay. Again, sounds philosophical, but underlies everything we'll do. But so all this is to say that numbers are insufficient as a way of representing information. We need more than numbers. So I'm going to show you a second data type. Since you have done some programming before, this should not be a surprise to you.
Mhm.
That second data type that I'm going to introduce to you is strings. Let me write it.
Mhm.
Second. Okay. Strings. So to write a string in this language, you use first double quotes and then you write whatever you want. And then closing double quotes. Just give this a run.
Sure. Hello world. Mhm.
Hello world. Yeah. So we didn't get back a number, we got back a string. And we
Yeah.
can do some stuff here like hello world and goodbye. Okay, what do you think will happen if we
Mhm.
run this?
It will concatenate, I think it's the word. Like it will just put them next to each other,
Okay, let's run it.
given
Let's
an.
see. Mm.
Oh,
So
huh.
the same way that we can add two numbers, we can add two strings, right?
Yeah.
Can we try changing the plus to a minus?
Mm. Hmm. Mm-hmm.
What's
Huh.
happening here?
Ah, okay. The operator expects only numbers.
So it makes sense to add two strings, but doesn't make sense to subtract two strings, right?
Yeah.
Okay. So we can perform arithmetic the same way we can perform arithmetic with numbers, we can perform arithmetic with strings. We can perform operations on strings, right? But the nature of the operations, the nature of the quote unquote arithmetic is different between numbers and strings, right?
Mm-hmm. Mm-hmm.
Okay, I'm going to do something a little bit different. So can you run this on your end?
Mm-hmm.
Okay, so here we see two different fives. We see a five in quotes, so it's a string, and we see a regular five. Five as
Mm-hmm.
the number. So here I have another somewhat philosophical question. Now that we have strings, and strings are a series of numbers, and a number is displayed as a series of characters, why do we need numbers? Why not make all values strings?
Wait, can you repeat the question? Sorry.
So we have strings now, and strings
Yeah.
are a series of characters, and the number is also a series of characters. Like that five, we have to type a series of characters to write that five, right?
Mm-hmm.
Why do we need numbers? Why not make everything strings?
Well, like for example, hello world, you want to communicate information to a
Yeah.
human. And in this case, I mean, we haven't tried it, but I don't think if I add this string five with this number five, I don't think it will give 10, for example. It will
Mm,
probably give an error because one is a string and one is a number. So it doesn't read it as the same.
very good answer. Very good answer. Yes, we can't do arithmetic with strings, like traditional arithmetic, right?
Hmm.
So, like for example, just now we couldn't subtract two strings.
Yeah, uh-huh.
Yeah. So while the same piece of information can be represented with multiple data types, there are strengths and weaknesses to each, right?
Yeah, exactly.
One
Uh-huh.
data representation might be better than the other because it might have an operation that we want, right? For example,
Mm-hmm.
like temperature, it's probably
Mm-hmm.
better to encode that as a number because we might perform math operations on that temperature, like degrees Celsius. Like we might want to change that to Fahrenheit, for example.
Mm-hmm.
Okay. Um, okay, I'm gonna introduce one more data type and then end with an exercise. So I'm gonna
Mm-hmm.
show another data type, and I think you've seen this one before. Okay, so the idea here is that we're encoding information, and another piece of information that's pretty important to encode is the idea of a decision. We say that it's often said that life is a series of decisions. In fact, the computers we have are possible because it's making so many, 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 many decisions at a point in time, right?
Mm-hmm.
And a decision is fundamentally yes or no. So the idea like yes, no, on, off, right and
Mm-hmm.
wrong, true, false, the idea of dualities, we encode that using a thing called booleans. So booleans, it's named after George Boole, a guy named Boole. He
Mm-hmm.
studied these things as mathematical objects. And in programming, it's generally called true and false. And it's true for this language right now. If you run this,
Okay.
we'll see true and false. So true and false are two values. And notice how they're colored purple. They are special
Yeah.
citizens in this language. Now,
Oh.
note how I cannot assign, like if you run this, let's see what happens. Doesn't work, right?
Uh-huh. Yeah. Uh-huh.
We can't use the word true as a variable because it's a special citizen. It's a
Okay.
special citizen of
Okay.
this language.
Hmm. Okay.
And we can also perform quote unquote arithmetic with booleans. If you run this, what do we get?
Ah, okay. I think I remember seeing this in mathematics.
Right? It's like we have two booleans and now we have one. So we're performing some kind of arithmetic on it.
Hmm.
Another operation we can perform is this. Can we try running this?
Hmm.
False or
Okay.
true is true or false is true. Right? We call this Boolean operators. So what you saw so far, you saw and now you see or. These are both Boolean operators. Boolean operators are they perform arithmetic on Booleans.
Yeah.
The same way we can perform arithmetic on numbers and strings, we can perform arithmetic on Booleans.
Hmm.
Um, I'm gonna share my screen for a second. You can keep sharing your screen. I want to show you something. Just give me 1 second.
Yeah.
So I'm sharing my screen now. Can you see it?
No, but I think I need to stop sharing.
Oh, okay.
Yes, now I can see it. Yes.
Okay, so here's a bunch of truth tables. So another way of understanding Booleans is that they encode truth. They encode whether or not something is true. So these tables are the definitions for how the quote unquote arithmetic, the rules of arithmetic for Booleans work. So just now we saw like false and true is false, 0 and 1 is 0. This is for and.
Hmm.
Just now we also saw 0 and 1 is 1. False and true is true for or.
Hmm.
So why is it like that? So the short answer is that that's just the way it is. That's just the rules of it. The more nuanced answer is that that's just these are arbitrary operations, and humans have decided to give these specific names. So for instance, if I ask you, do you have an apple and a banana, but you only have a banana, you'll say no. I do not have both an apple and a banana. But
Uh-huh.
if I ask you, do you have an apple or a banana, where you only have a banana, you say yes, I have a banana. I have one of them. So it's true.
Yeah.
So that's the
Yes.
intuition behind like these two names. As a programmer, the most important logical operators that you use is not, and or. These three.
Okay.
Um, what are these on top here? These are logic gates. Our computers are actually made with thousands, millions, trillions of these little things. Each one, remember how I said like a computer is just a bunch of zeros and ones?
Mm-hmm.
These are just the zeros and ones. These are the zeros and ones. These little logic gates perform the computation of these zeros and ones to convert them into more zeros and ones. And that's how computation is possible. All these soup of zeros and ones are constantly changing with these logic gates.
Mm-hmm.
Yeah. Um, you don't really need to know all these. Unless you plan to get into cybersecurity, you might need to know more gates, more building operators.
Mm-hmm.
If you're interested in electrical engineering, you're probably going to need to know these. Otherwise, you only need to know not and an or.
Okay. Okay.
Okay, I'm going to stop sharing my screen now. So I'm going to summarize everything we've done so far. We
Mm-hmm.
have covered the fundamental idea that our job as programmers is to facilitate the interaction between information and data. And I showed you three data types. So the term data type is a classification of data. So we say a number is a data type, a string is a data type, a boolean is a data type. I've shown you three of them. So these three, they're like cash. If you're lost in a city, but you have cash, you can probably get what you need. When you need to encode information as data, you're probably going to use one or more of these three things. Uh,
Okay.
okay, I think we are running out of time, so I think I'm going to wrap it up here.
Yeah.
Yeah, we lost a bit of time from the technical difficulties just now, but that's okay.
Yeah.
Uh, okay, but I guess I want to end this. First, I have a question for you. Like, so, like, how's the pace of this? Like, was that okay? Was that too fast? Was that too slow? Like, how was it?
Um, I follow, especially writing, and this also gave me time to stop and think when you were typing and I had to run it or vice versa. This exercises I liked. Um, the pace was good, but I was on my toes, which I think is a positive thing.
Okay.
Yeah.
I'd like to end my sessions by asking all my students this. What is one thing you learned today that stuck with you?
The foundation. Well, this idea between these two worlds, information and data, and that programmers facilitate the interaction between those two worlds because, what you told me with the number five, like given the context, it means different things.
Hmm, cool.
Mm.
Okay, so I'm going to wrap it up here. This recording will go on the YouTube channel, and it's going to
Hmm.
be, you will see
Yeah,
on the Lucas, the name on it, and you'll know that's yours. Okay,
sure. Awesome.
thank you so much for joining me here, and I'm very happy to help you on your journey in learning programming, and I hope to see you
Thank you.
again.
I hope to see you again too. Shall I just book it on the website, the next
Yes, the
session?
same
Okay,
Google Calendar link, that should work.
perfect. Thank you very much.
Of course. All right, bye-bye now.
Bye bye.